All right, welcome back. This is episode 6 of the Smartest Dummies podcast.
Name should probably change.
Uh,
Yeah.
yeah, well, today we're going to be talking mostly science again, computer science, neuroscience. We're going to be talking about the free energy principle, which was created by this guy named Carl Friston. We're also going to be talking about the Mars missions, and what's been going on recently
Recent development.
as of August 6th, 2020.
August. Yeah, it's August 2020. We are still, for future listeners, we're still in Corona.
Yeah, the coronavirus pandemic is still ongoing.
Full force.
What is?
We're number one. We're U.S. space, so we're number one.
That's not a good thing. Anyway, okay, so let's get into the free energy principle. What is it? And we listened to some videos, or one video.
Some clips.
It was the Lex Friedman podcast yet again. Such a great podcast. Again, we would like to recommend that podcast to our listeners for a more in-depth version of what we're actually talking about. Anyway, so Carl Friston, the guy who created the free energy principle, the idea of it, gave an example of an oil drop floating in a glass of water. And so where does that oil drop, the question he proposed is, where does that oil drop actually stop being an oil drop? Like, there are three kind of boundaries, three bodies within that body of water containing the oil drop. There's the oil drop itself, the interior of the oil drop. There's the sphere, or the skin, you could call it, the boundary of the oil drop and the water, where like the
It's
two,
external.
yeah, its external boundary with the water. And then there's the water itself, whatever the oil drop isn't. In this case, whatever the oil drop isn't is going to be the water that it's floating in.
And then what the free energy can help describe is why.
Not why, but
Or the purpose behind.
it can help you find the oil drop within that bucket of water.
Yeah.
Say if the oil drop looked exactly like to your eyes it looked exactly like the water. Like, this is hypothetical. Obviously, oil doesn't look like water, but say you couldn't tell the difference with your vision. Well, you would look for other characteristics. And what the free energy principle is it's a list of characteristics that help you to determine whether or not something exists. And an example that came to my mind when I was listening to this podcast is dark matter. Like, so before dark matter, before the theory of it, we were looking at the universe and we could see that it was constantly expanding. And we didn't know why, because gravity dictates that stuff should eventually, gravity dictates that stuff comes closer together, that there is an attractive force between any two given particles of matter or two bodies of matter. And given gravity and the universe as it is, the original hypothesis was that, the theory was that we would eventually crunch back up. You know how there's a big bang, well, there'd be a big crunch. Well, obviously this wasn't happening because the universe was expanding at an accelerating rate. And we decided that there must be something else we hypothesized that there must be something else out there that was doing this, and that something is dark matter. There's also a dark energy. Besides the point.
Yeah, it gets more in depth with the different types of material things.
There's dark matter and then there's dark energy. I've kind of forgotten the distinction.
But that's not important here. But
Important thing is,
just so you know, the main reason that we came up with originally with like dark matter and dark energy is because it's kind of like the yin and yang of the universe.
Well, the main problem is
it keeps
finding
expanding.
that something that it exists.
And there's another.
And that's what the free energy principle basically helps us do.
There's a more recent development on free energy as well, which is what Carl Frist was talking about. I think he came out with a new book, is what they were talking about as well. But basically, there's old mathematics systems. It's used popularly in computer science and machine learning. It's called the Bermudian. I can't pronounce it well, but basically what it's doing is it's finding it's creating some sort of guess in a system of what an unknown variable is, and then it uses known variables and finds evidence for those. And once it finds evidence of those, it can have systems of equations to try and guess whatever like trying to guess why or whatever. It's a computer solving thing. And then what he's doing here in the new one though is he's using something called the negative elbow. And it's another thing in machine learning, and what it's doing is it's an optimization of that, and he can use it here in free energy to help establish like the existence of something, and in that state in a system. And then there's a distinction though, and it's called what he was talking about earlier, between internal and external. That little sphere, the boundary layer, it's called the Markov layer.
The Markov blanket.
Markov blanket, yeah. And then in any system, it has internal, external, and then the is or whatever.
The Markov blanket is what separates the external from the internal, and
it can help establish.
So the Markov blanket is kind of a weird name, but if you think about a blanket, what it does is it covers something. Think of like a ball or a sphere, right? And think of putting a blanket over that three-dimensional like sphere. You already know that the sphere itself is an individual. It's separate from the atmosphere, the air. It's separate from your hand that's holding it. It is an individual object that you can define as a sphere. The Markov blanket is that idea. It's the boundary, keeping the definition clear. It's the fact that there is a definition.
Mm-hmm.
The fact that there is a definition of the sphere, the fact that the sphere exists means that there is a Markov blanket around. So yeah, moving on from the oil drop example, computer science and neuroscience, how the free energy principle relates to these two fields. So in computer science, they're doing this thing called artificial intelligence. I'm sure you've heard of it. And there's a problem with artificial intelligence. It's the fact that it doesn't move. And this gets back. Let me backtrack a little on the oil drop example, because there's this idea of movement, and the oil drop itself, it doesn't decide where it's going to move. The water around it and physics, Newton's laws dictate that there will be an equal and opposite reaction, so that the movement of the oil drop is from an external force, the water acting on the oil drop, and the oil drop pushing back with an equal and opposite force. So anyway, think of a tadpole, and what are the differences between a tadpole floating in water and an oil drop floating in water? Well, you could say that the tadpole is alive, and if you're going to be a little more specific, you could ask what makes the tadpole alive. And Carl Friston argues that it's the absence of randomness in the movements of the tadpole, and that we'll say the tadpole is hungry. Well, it will look for food. It's not necessarily a conscious, human level intelligence, but it does have a non-randomness to its movements, and he argues that that's a big factor for life in general. Mm-hmm. So, and he also argues that computer science needs to have that movement, that it lacks it now, and movement in the computer science world or the artificial intelligence world would be the ability to learn. And if you don't know much about artificial intelligence, neural networks can learn, but not in a strictly human way. What happens is we give them a data set, and they can make inferences about another data set based on the data set that we give it in the first place, but it's not going and receiving new data. It's just using that one data set that we give it to make all its predictions on other, and that kind of limits the functionality of it to a very specific function in some cases. In other cases, they can be more useful, but they don't learn. They don't grab the data from the environment that they're in.
There's some things, because like I know in some algorithms that people write, there are some exploring traits that they'll add, but that's directly thing. They like to really heavily rely on what Carl Friston describes as big data.
Right.
Just really large amounts of data, just trying to basically massively overkill instead of like what you were talking about, directly going to the food, like in the tadpole example.
And he said that there are basically two kinds of oil drops. He said if you like, literally, just as a hypothetical example, there's one that is very random in its movements. So random that in fact it averages out to no internal movement. And you can think of the oil drop as like, if you want to go into what's it called, what's it called when every little particle has its own kind of self-referencing kind of ability. Anyway, besides the point. So there are two kinds of oil drops. There's one that doesn't move internally, and there's one that does. And the one that does, you could argue, is alive. Of course, oil drops do not move internally, so they are not alive. And that's kind of the characteristics that you look for, and that's what the free energy principle kind of does in terms of determining whether something is alive or not. More basically, it's just used to determine whether something exists. But it's a little easier to think of it with this particular physical system, determining.
Yeah,
whether
he's really
something's
just Carl
alive.
Friston. What he's really trying to do with this example of movement as the defining of life or whatever, like intentional movement instead of randomness. It's really just trying to make a. He wants to be able to have a mathematical answer to a really complex problem, which I think
He's
is
trying to generalize a lot.
it's always going to be a really difficult thing, no matter how much more we learn about like the fundamentals of things or the giant relativistic thing, fundamentals of things. It's always going to be a really difficult question because people always want like a really clean answer, but whenever it comes to things like this and things like another bit back to the Lex Friedman podcast, they were discussing the difference between self, like in consciousness, like in something being alive. At what point does it turn over to self-reflectance, where it knows itself exists and things like that? And then that point as well. Or what about the point where between a virus and a rock, is a virus alive at all? And what point from a virus to microorganism?
Or a virus or an ant,
Yeah.
That's another example they used.
There's always all these lines that we try to draw in the sand that are just really aren't clear. And for the purposes of experiment, they're rather important. And so it's really nice to be able to have like a generalized statement like that to our knowledge right now applies basically everywhere.
Well, he gets into consciousness, and Lex Friedman asks, using the free energy principle and these generalized, boundaries of Markov blankets, is it possible to think about or to draw a line where consciousness starts and ends? And what Carl Friston said was that basically he said there are different types of consciousness. You have the consciousness that might be found in a virus, and you have the consciousness that might be found in an ant. And in a virus, there isn't going to be any planning, and definitely not any self-reference, or in other words, like consciousness as we traditionally think of it. But with an ant, it's going to interact with other ants. It's going to, it has a very specific purpose as well as the bacteria, but it does interact and it does actually plan.
And I know, I know for me, whenever I think about this problem and I'm thinking like, what's the best way to draw the line? And then I start thinking, we wouldn't even know where to start with the variables. Like, could we use number of like cells that are used to quantify data, like neurons and people and stuff like that?
Yeah.
It's like, it's really hard to even define the variables that we're looking for. And so that's why we're having to use like ideas like these traits and habits of things, just like we do with everything else. Like with everything from, the like atoms and stuff, how we quantify those by hydrogen atom typically, has one proton and then an electron, and then sometimes though it wants to have a proton and a neutron. It's a dihydrogen atom, but those are only 5% of the time. We don't know. It's always just habits and traits of things on these things that we're not able to quantify because we're not sure what variables to use. It's just really complex, and so that's why we're having to use these sort of like habits of, they like to do this, and it's really difficult to.
Yeah, it is. And moving on from computer science to neuroscience, Carl Friston himself is actually a neuroscientist. So the free energy principle, I guess, at its best, or at its most basic, purposes, is to help with neuroscience. And when you think about the brain, historically, people used to think that certain parts of the brain had certain functions, and that there was kind of a hierarchical layout to the brain itself. A little later actually, we used to think of the brain as just a big soup of interconnected neurons. That was once we had started actually dissecting the brain in more detail and having accurate drawings of individual neurons, or maybe not individual but clusters. And then later, actually, we switched back to the idea that there is a hierarchical layout to the brain, and that there are certain areas that function, that have a specific function. And the free energy principle theoretically could help, define those areas even better than we have defined them now, because the brain is still interconnected. All the pieces are interconnected, but determining the measure of the interconnectedness is something I don't think we have had much progress on, because at the most basic level, it's going to be the actual neural circuitry that takes place, that is occurring in the brain, and that's something we haven't done yet. Map that level of detail. Carl Friston, actually earlier in the podcast, argues that he would not recommend going down that pathway of mapping the brain and all of its molecular circuits.
Not to mention, there's just like in a single species, for example, humans, our brains tend to be the same way. We tend to have, our brains work in different ways, but person to person, it's completely different. The circuitry on each person is going to be different. And so,
right.
with you're not ever going to really be able to say, okay, here's the roadmap of a brain, unless we go back take one step back real quick into the computer science. That's what they're trying to do.
Right.
And then they're trying to relate the neuroscience roadmap that isn't even developed. They're trying to put a map on a computer system to model something that we don't even understand completely because it's person to person.
Yeah.
And that's the biggest issue right now facing that. And between computer science and neuroscience, those have always been like closely related. Because like with everything, we relate what we build to what we know biologically. Like planes. We see a bird flying, we're like, I can build wings. Same thing with here. It's like we start making machine learning algorithms and then neural networks and stuff like that to try to model things that we know is currently working. When in reality, we're not sure why they're working. And that's what the free energy principle still, it's not really determining why at all. It's more just determining, okay, so we know this exists.
And
then
where are the boundaries?
Where are the boundaries?
The different objects the different systems that do exist.
It's just getting mathematical bounds.
And
what it's doing.
On the thought of what Carson just said about how computer science is trying to model the brain itself, like even on the physical level of neural circuitry. I think Michael Kaku once said that the only simulation of the universe is the universe itself. And I think this is in response to Lex Friedman asking him, do you think that a simulation could be accurate enough to make you believe that you were no longer in a simulation? And that's how Michael Kaku responded. And I think that can be taken on terms of computer science and neuroscience as well. Like, how far can you get, before you just have to make it an exact replica of a brain? And that's an important question because the brain is a supremely complicated system, probably one of the most complicated parts of our body, the body being the most complicated system, that we know of. So it's a really important question to ask, like, how close can we get? What should our expectations be of these artificial intelligence systems and of those systems of the future? A lot of people think that AGI, or some people think that AGI is possible, artificial general intelligence or intelligence on the human level, but you should really temper your expectations because it's really complicated.
And what I think, whenever I start thinking about this, I even think, like, there's no really reason for us to want to model a brain because the goal of this, to be able to model the brain, is to be able to do better.
Right.
If we can't do better than what the brain, there's no use for it because we already have people. The whole point of this is to try to replace them to make it easier and more efficient. And if we can't even match them...
Right.
But
that's the end-all dream. Like, obviously, you can make lower functions for, say,
They're
a robot
useful.
that wants to clean the house, It's still useful, but like Carson said, the end-all dream for artificial intelligence, in a sense, is artificial general intelligence. Something supreme, something
that
better
we
than
could
humans.
define as a conscious intelligence.
Yeah.
And I really think that this can. We talked about in the previous episode of our podcast. We were talking about how, what's the line in artificial intelligence sense of whenever it becomes conscious. And I was thinking about this, and I really think that we won't ever really be able to get that. I said in the last episode, but I do think that we can simulate it to a point. Because remember how you said, what was his name, Michael Kaku? He was talking about how we could only simulate, the only simulation universe is right now. I think that we could probably have such a good simulation on a person that we could completely make you believe it. And I really think that's good enough. I don't think that we need to fully have all the interconnectedness of our brain, because this is a completely different thing. It's not a brain. It's a computer. And I don't think it's necessary. Right. If we can just convince ourselves and the resources everywhere else, because we only need pieces of our brain.
Yeah.
We don't need to be able
to do
everything.
The fact is, if it gives us something better, it gives us something better, you know.
Even if it gives something in one thing in particular.
Like, so you're arguing that the structure of the system, the artificial intelligence system, doesn't necessarily have to mimic the biological system as long as it gives you something better.
Yeah, and
there could be a better way out there.
Because we only need it to do one job.
Not a better way, but a variation of the biological way that still gives you something better, you know.
Yeah, and I think this has a lot of applications, like anywhere from flight paths of a rocket that's going through space to avoid all obstacles, because we don't want to do all that in future flight missions that want to be marketed as, or even just like driving down the road or transportation, all sorts of different applications.
And transportation, there's another interesting podcast episode that I listened to about computer vision. And really how much of a struggle it is to have an actually full automated vehicle drive the roads.
I'm going to plug right now, because I know we're allowed to show it right here in the middle. There's a really interesting clip of Tesla showing what their computer vision sees in their cars and how it recognizes every little thing constantly on any given road path.
Yeah, and everywhere. It has to generalize. You know, it has to figure out, well, this thing is actually not a person. What is it? Oh, it's a marking on the road. You know, it has to go through every step.
Yeah, and it's a mathematical thing of what we take for granted.
Right.
And this just really is a beautiful thing of artificial intelligence, having a really good ability of mathematically knowing where everything is in a given
And maybe
space.
we could link how much data they've actually, put through this system, because it's a lot of data. I don't remember the number, that's why I said we could reference it, but, it's a lot. And it's still not ready yet. And that's, that's to show you how complicated, the system can be.
And there's another thing that we wanted to talk about today. Speaking on the terms of Tesla, there's another company, because I'm kind of a electric car fanboy, I guess you could say.
Or Elon Musk.
Well, more specifically,
so that extends to rockets, that extends to flamethrowers, and whatnot.
A lot of different things. But electric cars, I really like talking about them, I really like looking at them. But what I'm really been fascinated with lately is there's a lot of different competition that's coming in, and it's such a great thing because it's going to drive the price down, and it's what we need. Same thing with rockets. Everyone noticed that all of a sudden we're shooting a bunch of stuff in there when there's a bunch of private companies all developing. It's the same thing. And then there's another company. It's really funny. Nikola is the name of the company. Tesla, Nikola Tesla. Like, they literally named themselves after the same person. Here's a picture right here. It's their newest truck. They just came out with it, and you can pre-order it now. It's actually really cool. It's basically the Cybertruck, just it looks like a normal truck. And it's really cool, and I think that one's going to sell. I really do. And then there's another one that, it's an electric Mustang, and they revealed it at, do you know what that's called, that electric, they came out with a bunch of TVs. It's this really cool convention they do every year.
So, what's the difference between, what's the difference between, the Nikola company and the Tesla company?
Okay, so I think the biggest difference is their battery types that they use, because I know with Tesla, they're kind of secretive about it. They use a bunch of little cells and all this other stuff in their board, in the floor. But I think with their company, they use a slightly different engine things to get, I think they like to focus more on mechanical things to get better leverages and things like that. And then their batteries are inferior, I will say, but their truck goes 0 to 60 in 2.9 seconds and has 900 foot-pounds of torque.
Yeah.
And I think it's really cool. And then another thing, though, with all these electric cars and other cool stuff going on, and switching away from gas. And another thing I wanted to talk about today, it's the difference between hydrogen, electric, and gas cars, and all the new things that are big coming out. Because everyone on the road now, they see Tesla cars, all this other cool stuff, and Priuses. And specifically, the company that makes Priuses, they're talking about investing in hydrogen cars, and they already have. And their reasoning behind this is, okay, so here's the hierarchy of efficiencies in cars, if you don't know. It goes, gas cars, they have like 20% efficiency in getting the gas to the gas station, you putting it in your car and paying for it. This is cost efficiency and the energy of you going. And then actually putting it in your car, paying for it, and then getting on the road and going. And then actually making the car, of course. And then you look at hydrogen. It's a little bit above that. It's like 30%, right? And then you look at electric. Electric is obviously way more efficient. It's super simple. We have a big grid. You can charge it at home. It's super cheap, but it has one fatal flaw, and that's that you can only charge at home. Superchargers aren't everywhere. It's not easy. It's not like it's the same reason that a Coke at the front of the store is $3 cold when the one in the back is $1. It's just convenient, and that's why Prius is betting all their money on hydrogen cars becoming the next big thing. Because it's already there. It's established. All they have to do is add another hose at the gas station that says hydrogen. And then add in their tank and fill it up. And they're everywhere. And so it's really easy just to fill up your tank with some high quality H2O, maybe some other chemicals, and then get going on drive.
Oh, okay, so
even though the efficiencies are lower, it's more.
So you can fuel it with water? I didn't know that. I thought you would give it just hydrogen gas.
There's a couple different ones. It separates it. What it does is it uses this really cool, because I'm not sure what they're going to use, because there's a bunch of different safety reasonings. Because hydrogen itself is just, you'd have to have it super cold for it to be liquid.
Oh, okay. So it's actually liquid. It's not.
You'd probably just use water or something. It'd be something.
Well, it's some kind of. I don't know if it's water.
I mean, yeah, it would be some compound.
Yeah.
It has hydrogen.
Some liquid.
And then, but basically, I only know the separation process for water. Use these 2 electrodes in these little tanks, and you use these little pellet hydrogen things that are really expensive, but you don't have to replace those. But they're working on all that, obviously, and then the rest of it just works like a normal engine.
So you could say that these companies that are doing hydrogen cars are concerned about the efficiency you wouldn't normally think of. Like when you think of efficiency, or when I think of it, I would just think, oh, well, you're not using gas, so you're saving the planet. You're using electricity, but they're trying to figure out a way to give you that fuel, more efficiently. And then, which makes sense.
Yeah, and they're focusing on actually getting it to you. It's the same reason why people criticize people for doing big things, because there's a better way of doing it. And it's like, yeah, there's a better way of doing it, but I actually did it.
Yeah, in my eyes, it's kind of a short-term solution. If electricity is actually more efficient,
and they
at powering the car.
They admit once there's a better network for electric cars, it's the future.
Right.
It really is. And I just think
it's cool to see that other take on it.
Yeah, it's really cool, and they're focusing on the now, and trying to get it, because it only the only thing that it spits out is water vapor, so it's like it's chill. I mean, electric cars spit out nothing, but you also got to keep in mind electric cars, their impact in actually making it is significantly more than a gas car.
So. Making the electricity?
No, making the batteries.
Oh, the batteries. Okay.
To manufacturing the car, you also have to take that into account of emissions. Okay. In a gas engine, it is a little bit less. For manufacturing the metal and all that, it has emissions. However, once you actually get it and you drive it and you're using the gas, over time, it's a lot more. But
so there actually are some variables you wouldn't.
Yeah, there's a lot of different variables.
Yeah.
And then I was looking at one. I think it came out of the New York Times or something stupid, one of those dumb big media things. But basically what it was saying is, the best way for you to help the environment or whatever car you have right now, drive it to the ground, let it break, fix it, and drive it some more.
I guess they've worked out all the math. They know all the variables.
Yeah. Oh, you know who it was that said that? Jerry Rig Everything. That's a channel plug. He says the best way you want to help the environment, whether instead of going and buying a new Tesla or buying a hydrogen car or a Prius, whatever car you have right now, drive it to the
And
ground,
then once
fix
it does
it,
break,
drive it again.
well, once it does break, then I guess you
Yeah,
can buy a
then buy a
hydrogen
new one.
car. Yeah.
Because the impact, people often overlook the impact of actually making and manufacturing the car, which has a lot of emissions. Because I think I remember reading somewhere, there's more cars than people.
Really?
In America, I think.
In America or in the world?
No, I think in America, because
Okay.
in some countries they mostly use bikes and shit.
Okay. Yeah.
So, no, but yeah, the whole thing of emissions really, it's a big thing, and it is important. A lot of people like to overlook it and just straight up blatantly say they don't believe it exists. Like,
Well,
they don't think global
carbon
warming
emissions
exists.
definitely
It's real.
exist.
Like,
Yeah.
just like in the 1900s, everyone was using those aerosol cans, and we had a giant hole in the ozone layer.
Well, just like any
It's in
chemical
Australia.
system, it's gonna have to
Yeah.
get back to equilibrium somehow. You know,
Mhm.
whatever the effect may be, the effect is there. You know.
And then, not to mention, the biggest impact I know right now in my mind when I think of not helping with our whole carbon emission crisis is, okay, in the Amazon, as you'll know, it's the biggest rainforest, the whole biggest collection of organisms in the world. And there's an issue with, there's not a lot of government out there, there's not a lot of rules. So what people are doing, these companies are coming in, they're not asking anybody, they're not talking to anybody, they cut down 100 acres of trees, take it and leave. And no one's going to say anything, because who's gonna, right? I mean, and they pay the locals, they're happy, no one cares. And they're just buying land off people and chopping them down. And they're not replanting it. And that's one of our biggest issues right now is, Mr. Beast did the Save the Trees initiative, 20 million trees, team trees. That was cool and all, but then you think about 20 million trees.
So was this story that you heard about the companies coming in and chopping down like 100
That's
acres?
recent. That's right now.
Was that in the big media, or was that something you just had to find?
No, it was
it
a co-star on the Joe Rogan podcast.
Okay.
It's he was talking about what's his name? But what he does is he goes into the Amazon and all these other different places.
I've heard of him.
He tries to save the pygmies. It's these. I think his is more in Africa. I'm not sure. He goes to a bunch of different places and tries to help people. And what he's doing though, I think he mostly goes to Africa, but he's been to a lot of different places, and then he tries to help people. But specifically now, he's focusing on these group of people called the pygmies. They've been oppressed and kicked out of their land and given like 100 acres of junk. And then they don't know what to do. They haven't been taught literature. They haven't been taught anything. He's not affiliated with anyone. He's just a nice guy. He's gotten malaria like 3 times. He has a parasite in his brain right now that they don't even know what it is. Like, he has some crazy stuff, and he's just a cool guy. I'd really check out that podcast. I can't remember his name, but I'll plug it in the description. I just listened to it recently. And he went in depth about that a little bit, about the rainforest and them just chopping away, because no one's gonna stop you. It's money,
and
they're broke, they need money.
Yeah, and with the environment and all this stuff going on, there was another guest, on the Lex Friedman podcast that talked about existential threats as far as the environment goes, and I forget what exactly they talked about, or how they got into this subject, but Lex asked him, well, do you think that decreasing our carbon emissions by, the standards that are being,
withheld against them?
Well, no. Do you think that what we're planning to do with how we decrease our carbon emissions is going to actually, affect, do any good at all? Is it enough? And he said, absolutely not. He thinks that it will have to be really extreme, like similar to what, whatever those crazy left-wing liberal nuts are.
A lot of extremists.
Yeah.
I remember seeing some research from a couple years back. You can find all these clips on YouTube and stuff. It's just a bunch of different people trying to come up with ways to take the carbon out of the air and all this different stuff. I think it's going to be a combination of that, a drastic change in ruling, and really harsh laws. Like harsh laws that they're going to kick people out of jobs. They're going to shut down companies. They're going to have a lot of completely different change in our direction that we're going. And this is necessary, in my opinion, because we had such an explosion of technology and manufacturing that no one could have known that this kind of stuff would happen, like this kind of impact.
Well, yeah, and another thing, just generally with like the chemical aspect of what's going on in the atmosphere, like I don't really know the chemistry behind it, but it seems to me that I don't know what the methods are, but using certain methods to take carbon out of the air will give you a byproduct. Maybe not, maybe so, but it seems like chemically it might be kind of tricky because if you think about like the environment and the atmosphere and weather and predicting weather and like how there were programs back in I don't know what year a while ago that were trying to influence the weather based on how much chemicals they dumped into the atmosphere, and those were completely totally unsuccessful because of chaos theory and that realm of physics.
Yeah.
And
which we talked about in another podcast. I think
Yeah.
that's number 2.
and it just doesn't seem very plausible to me to dump chemicals into the atmosphere. Of course, I'm not a
Well,
scientist,
yeah.
but like based on what I've heard.
What I think the biggest things that we can do to cut back and to really make a large impact is, 1, manufacturing in general, we got to come up with new techniques. 2, like everyone drive less in general, which we are right now due to COVID. We're kind of being forced to.
Yeah.
And then another one, this is one that often gets overlooked, and this is the agricultural industry. These are the people who are breeding cows, breeding pigs, trying to feed people.
Oh, dude.
We have a lot of people because this exploded tenfold of manufacturing, and this is single-handedly one of the biggest carbon emitters everywhere.
Wow.
And then the biggest issue with this is how they're farming. Because it exploded so quickly and they had the only option they had was, as we all know, the really kind of agreeably awful factory farming. Everyone has a foot of space. You're in a giant building. Eat a bunch of crud that we don't want to eat.
Yeah, it's pretty
A bunch of waste. But there's a new form of farming that's coming into effect right now. And then, what was this called? Basically what it is it combines the agriculture of growing food, like in your field, right? So there's this technique, everyone knows about it. You grow food in a select bit of soil, right? And then the next season you move it over to another bit of soil so that you can let that soil rejuvenate and come back to full, nutritional value, I guess you could say, for the plants next year so that it'll grow just as well. It's like this switching, right? And then what they can do is they use the same technique for animals. And when you can do this, you can feed them in this area, and then you move them over. There's a whole technique about it. There's a bunch of papers written, and you actually can get carbon negative doing this.
Really?
Yeah, doing this specific technique.
It would be inefficient, though.
But no, that's one of the biggest issues is converting this over, because we have this giant demand for food that needs to be met constantly, and it takes time to get it into fruition. But I remember, I don't remember where it was. It was a guest on Joe Rogan again, and once again, I'm a Joe Rogan fan. He said it takes I think he said a fourth of Utah would be enough space to feed America using this technique.
Really?
Yeah, like a fourth of Utah. And
I don't know. Texas farmlands are pretty massive when you drive through them. It seems pretty big.
Yeah, well, you also got to keep in mind.
I guess this is cattle, right? This isn't for
This is like meat, yeah. This is meat.
Okay, meat.
This is meat only.
Okay.
But obviously, plants and all that take a little bit more space. But that industry doesn't have as much carbon emissions, I don't think.
No, plants will take in the carbon and.
Plants are good.
Nitrogen. Yeah.
But see, that's another thing too with everyone trying to take carbon out of the air. Trees kind of beat us to that. It's their whole job. It's their whole thing.
Well, the problem is that we're cutting down trees.
Yeah, we mentioned that in the last podcast, actually. Oh, wait, the one before last, the fourth one, that was 4 months ago.
If you didn't know, you probably learned in elementary, if you forgot, trees do in fact take carbon out of the air, and
that's where they get their mass.
Yeah, is it oxygen?
Oxygen. Yeah, they emit oxygen and a couple other things like water vapor and...
Yeah, trees are pretty awesome.
But actually, another fun fact is we mostly breathe nitrogen.
No, but we don't breathe nitrogen. The atmosphere is made a lot of.
Yeah, well, I mean, in our air, I think it's 21% nitrogen.
Yeah. We don't necessarily thrive off nitrogen. It's mostly oxygen.
But it's not just oxygen that we're breathing, is what I'm saying. It's a mixture of things. We breathe a lot of different stuff. And then actually, when you exhale, people like to pretend it's all carbon. It's actually just part carbon. Mm-hmm. And that's also, have you ever noticed, in the morning, you, weigh less? Have you ever noticed that?
Didn't Veritasium do a video on that?
Yeah, we talked about it in the fourth one as well. with trees and all that. Yeah, everyone has to go check that podcast out. I think
Yeah,
that
we'll
was
just
our
leave it
first
at that.
film. That was really good. All right, so
let's go
moving on.
to
We need to move
Mars.
on. We've been on
Yeah.
this topic too long. Let's talk about Mars.
What did you want to talk about exactly with Mars? You were mentioning the new rover.
Yeah, okay, so Perseverance just launched, as probably a lot of y'all know. I think it was...
what day? Do you remember roughly when it was that it launched?
I want to say it was the 1st of August. I'm not
Okay.
sure, though. But I'm pretty sure it... I'm trying to think what company NASA teamed up with. I think it was the... I don't remember, but I don't think it was SpaceX. I think it was another one. Anyways,
There's a lot of them.
besides the point, yeah, there's a bunch now, which is awesome. They launched Perseverance. It's basically the Curiosity rover because don't fix something that's not broke.
You said its main goal is...
Its main goal is to find life on Mars. It's ideal. Hopefully, if it makes it there in 6 months, it'll arrive. Hopefully, cross your fingers. It's going to be landing in this like large crater, which is believed to be an like ancient lake ruins, which we're hoping we can find microorganisms there. And if we can, this could prove a lot of different things for us. Maybe certain plants can grow in here.
Certain theories of evolution.
Certain theories of evolution, different non-carbon based
Or maybe it'll
life.
give us, even better, maybe it'll give us some questions.
Yeah. It'll broaden our questions. And then there was another thing with this. It's kind of funny. It has the possibility in a couple years, maybe, if it's still going, just like Curiosity did, it could maybe go and dust off Curiosity.
Oh, really? Is Curiosity
Remember
shut down? I have no idea what's
so
going on.
there was a
on
big
Mars.
meme going on for the longest time.
Yeah.
Was that a good moon rover? Basically, the Curiosity rover, if you don't know, it had a drilling bit. I think it was launched in like 2009 or something, or early 2000s. It was on for like 13 years or something crazy when it was only meant for 90 days of activity. And it just drilled into the Martian soil and then just into a bunch of... saying what its composition is, take a bunch of pictures. And then actually more recently as well, we've gotten the first footage, the first videos of Mars in 4K.
Oh, yeah.
You can see those right now. There's a video on Mars, which is crazy. Well, it's stitched together images that are... But it's video. It's video. It's really cool. And then also, that's another thing with Perseverance.
Yeah, that's about as close as you can get to actually
We're going to
being
have
on Mars.
audio on Mars with Perseverance. There's
Really?
mics. We're going to have
Well,
audio
you're
of
probably not
entry.
going to hear much.
Yeah, I mean, you're not going to
I don't know how thick the atmosphere on Mars is.
But we're going to have audio of entry and then
That's
audio
cool. Yeah.
of actually landing. We're going to have... Maybe there's aliens. They can say hi or something. I don't know.
Yeah, maybe so.
But there's microphones on it. They have more scientific purposes, I'm pretty sure. I think it has to do with like wind or something.
Oh,
But
actually measuring...
I think they do other things that are kind of more important
yeah.
than just
and
audio.
talking to aliens?
Yeah, but and then more exciting news is Starship with SpaceX. It's a program that they're doing to send humans to Mars, hopefully by like 2025 or something crazy. And
Something relatively soon.
Something relatively soon, which is insane. They built it, right? And it's going to be running on methane fuel, which is really interesting. And the reason they chose this is because, contrary to popular belief, they plan on coming back with some people, hopefully. Or, well, not the first crew, obviously. But they do
Really?
plan on doing some launches. I think they want to
So they're
launch
going to leave
satellites.
people over there?
Yeah. First group's staying over there forever till they die.
Oh, wow.
Yeah. But they have like 200,000 candidates already, so it doesn't matter. But anyways, yeah, so Starship's going to run on methane, and it's going to get there, and they have a bunch of different reasonings for this. Obviously, the Martian atmosphere is thinner, but it still creates a lot of heat on entry. And so you got to imagine when it's coming in, it's creating a lot of heat on the belly. It's going to release some of the methane fuel, and it's going to act like sweat on the body, cooling it down. And then it also has an effect. There's frozen methane on Mars, so we can use that.
So now that we have the technology, for rockets, we need to figure out how to mine it on Mars, but we have
there's a lot more steps, but we're trying to put it into motion.
Okay.
And they actually also gave it a solid steel body, which was well, it's not actually steel; it's like an alloy, but it's also really interesting. It's heat resistant and strong. And
the question is it radiation resistant? That's the problem that we're going to get into.
Yeah, that's another thing we need to talk about. Because the Starship, it did a bunny hop today. It went like 4 stories up and re-landed itself. That's cool. We've seen it.
Yeah, a lot.
A big thing he mentioned to me before the podcast, if you want to go into that.
Right. So again, I'm getting my information from the Lex Freedom podcast, and again, I would like to, inform you of that and maybe get you to listen to it someday. And the particular guy that was talking this time was Jim Gates. He is a theoretical physicist, and Lex Friedman asked him about the Mars mission and how soon does he think that we'll actually be on Mars, we're getting to Mars, and he said, "Boy, it's looking not in the near future." And he said that because there's this problem of radiation, cosmic radiation that the astronauts would be exposed to when they were flying to Mars, right? And that radiation over a long period of time can lead to cancer. And so the question is, how do we prevent that radiation from penetrating the ship? And I don't know the science of it, but that's the problem. I don't have any hypothetical, solutions
Yeah.
even. And that's what the problem is. You don't see that in the main media. You see, oh, this rocket landed itself for the 10th time, right? And that's, in my opinion, and I think in this other guy, Jim Gates' opinion, just a marketing scheme, which is important. Money is important, but it's not the only problem. There are other problems that are arguably even more
It's difficult,
harder to solve.
and we can't take away from it. But it's not that it was a big accomplishment.
Yeah.
But we did it in 2008, so it's like
right. And he described our progress as incremental. And he described the progress that he theorizes that we will need to get to Mars by 2030 as leaps and bounds, exponential.
But another recent development, I think, is the possibility. But this is really difficult because obviously 6 month trip, you're gonna need a lot of water to drink for people to drink, and this may not be known, but water is actually really popularly used in containers. Well, not just plain water, but other stuff in it, to prevent radiation. There's
Really?
containers and stuff to for radioactive isotopes.
Sure, it's
to
a
let it go out.
certain wavelength. Of
Yeah,
radiation.
there's a possibility of storing it in the walls that can help reduce. And this is just a really specific technique. There's a lot of different techniques that are going to be
Maybe you could have
used.
multiple layers, like a layer of water, a layer of lead, whatever.
Yeah.
The
And-
wavelength out there that needs to be, reduced.
And then more
or stopped
specifically, the issue isn't making things that are radiation proof. We can do that. We can more than handle it. The issue is keeping it weight efficient
right.
to launch into space.
Lead is heavy. It's one of the heavy.
And so what they were also considering doing is, although cosmic radiation is constant background radiation, it changes as you move through. So what they would do is as they're moving through, let's say there was something intense, for an extreme example, a solar flare. It misses Earth, but it's heading towards the ship. They can't dodge it. They gotta stay on course. They will have this small container that can just hold the crew and some of their essential life-saving items. And they would go sit in there and then shut down whatever systems they don't need so they don't get fried. And they would sit in this capsule that's weight efficient and then just sit in there and ride it out and get sitting there to avoid the radiation. That's one technique that's possible, and they can just constantly be looking for things like that. But the issue with that is they would have to see the solar flare first or before we do on Earth.
Oh, okay.
Because we can send a signal to them, but
So they would need the same device that we use to detect it.
we're also going to have to take into account the time it takes to get a signal, because I think it takes 8 minutes or something like that.
Well, I
But
think it
and
takes
they would have 30 minutes to get ready, which isn't a lot when you think you're on a ship.
in any account, it takes time, to send that message.
Yeah. And this is another recent development too, is we're looking into some different laser information options to use lasers as our new communication standpoint with satellites and intercommunication with satellites and then into rockets, sending a bunch of beams of lasers.
I've heard of that, and there was some drawback. I don't remember what it was.
The biggest one being that you would constantly have to evaluate your distance from it, which would take another laser because you need to know how the wavelength changes. Because with large distance like that, even though it's really slight from here to Mars, it still gets redshifted a little bit.
Okay, so basically the raw data, the ones and zeros that you're sending would
It
be
get
altered
corrupted.
a bit.
But
So
you
you need
can-
a decoder.
You would need a
essentially.
decoder, but so
Yeah.
you'd constantly need to have a distance measurement.
Huh.
But this is easily done with things in orbit, but whenever things get further out, it's near impossible. But whenever things are in orbit, it has some really good advantages over other communication standards.
Yeah, and I forgot to mention the radiation problem. Just to backtrack for a second.
Oh, yeah.
The reason that people are able to stay in the ISS for so long is because there's still protected by the Earth's magnetic field.
Mm-hmm.
You know, it's going to deflect most of the radiation. And the moon landing, of course, you know, they were a little more exposed, but they weren't exposed for as long as the, you know, people on Mars that would be living on Mars, you know, would be exposed.
And then you also have to keep in mind that the moon landing, they used like the single largest rocket ever made, the single largest vehicle ever made. It was gigantic. The weight was huge then. Like they used a gigantic engine. They had a lot more funding. They used NASA, and
there's a huge push.
There was a huge push,
Monetary
and
push.
so they had a lot of equipment. They didn't skip out on bells and whistles.
Right.
So,
and that's another thing that Jim Gates said. Lex Friedman asked, well, you know, maybe if we had a ton of money poured into it, what would you think about our chances then? And he said something along the lines of, it would still be hard, but it's definitely a motivating factor to get something done, obviously.
Mm-hmm.
But still, in his opinion, it's going to be a little bit, you know, because there are fundamental engineering problems that still need to be solved, you know.
Because people see, like... Okay,
it's not just a problem of funding.
Yeah, people see that they're landing the boosters, like, they're making all this money from NASA, like, they're getting all these $30 million, $50 million contracts, but they're still not seeing the tight budget. Like, it's a really tight budget. So it is important, and I think that's going to be... That was another reason for the steel body on the Starship, was because it's cheaper.
Hmm.
Yeah.
Yeah, money's really...
Money, yeah. Especially in such large craft. But anyways, the radiation problem, we'll leave that for the material scientists.
Right.
And we can move on.
Cosmic radiation scientists.
Yeah. Well,
that's basically all we really wanted to talk about today. If you're not paying attention to the news, I guess this is just kind of a...
There's little things going on.
Yeah, there was recently an explosion in Beirut.
Super large.
Actually, let me look up what day that was.
Yeah. And there was like
Just
these giant shock waves. There's so many videos you can find online of it like propagating. You can actually visibly see it. Because as you know, like shock waves and the way things move, it moves at the speed of sound, and the speed of sound changes through different materials. That's how everything moves. And that's why, like, a really good example of this, if you're in like a kilometer long tunnel and you have a metal pipe and then you yell at your friend from the other side and you bang at the same time, they'll hear the bang before the yell.
Yeah, and from a humanitarian stance on this topic, you know, obviously it's really sad that it happened, but we're actually still trying to figure out what did happen. As of right now, at least 100 people were killed, you know, thousands injured. It's really awful what happened. And they don't know what started the fire. It was an ammonium nitrate explosion that the fire ignited. And, yeah, we're just keeping them in our thoughts and prayers because it's really terrible. I watched some footage on YouTube and from, you know, the news broadcasts of what, you know, the city looks like now. And it looks like what you would see in a movie. Like apocalypse type images, you know, it's really
like Chernobyl meltdown type stuff.
No, like everything's in ruins. Like all the windows are broken. Everything's just scattered. There were cars that flew. You know, I don't know how far. There were people that flew reportedly miles. You know, I don't know if that's accurate, but it was really terrible, catastrophic.
I remember I saw a video from like a mile away of a guy a guy driving down the highway in his car. He was recording it because it was on fire. You know, it was a giant fire for a while.
Before it exploded.
Then it just exploded, and he watched as the shockwave like came towards him. It exploded, all his airbags and all his windows shattered at once. Probably caused permanent hear damage.
Yeah, I mean it's really awful. There was another view from a boat. I don't know where they were boating. But yeah,
like a lake or something.
You could see it for miles around. You could actually feel the blast and hear the blast. I don't know if they could hear it all the way in Cyprus. If you don't know where Cyprus is, it's an island off in the Mediterranean, you know, a good distance away from Lebanon. It's really insane what happened. Anyway, I guess to end on a more positive note,
explosions aren't fun.
Well, no, I was going to say, like, yeah, just listen to the Lex Friedman podcast if you haven't started already, because I'm going to keep mentioning it, whether you are listening to it or aren't listening to it. So you might as well just listen to it. We're going to leave some links in the description for you to get some of the best content from that podcast. I mean, it's all great content.
And make sure you keep coming here before you go to them. Though.
Right, because we're a dumb version of what's going on there, and maybe
we're just two idiots trying to understand.
Maybe you can relate to that.
Stuff.
Yeah. So anyway, we enjoy doing this.
And
hopefully you
subscribe.
enjoy listening. Yeah, if you want to support the podcast, definitely like and subscribe.
Upvote.
And we will, in case you were wondering, be working on getting it on Apple Podcasts shortly. Other podcasts.
For people that prefer audio only.
Right.
And then we also we have a new schedule. Hopefully it's kind of rough right now.
We're trying to do it as often as we can, but we're going to shoot for Tuesday, Thursday uploads every week.
But if not, just kind of plan on every 3-4 days, something like that.
Yeah.
We're working as best we can. Obviously, with school starting up soon, it's going to be changing. But yeah. Good.
Hope you liked it. See you next time.
Keep getting better.
Yeah.